Okay, day 3. Two examples. A pulley, what we have, in 1.5 seconds, 25 inches of belt wrap around the pulley. The radius is a half a foot. Can you find the angular velocity? Okay, when the test comes along on Monday, if you can tell me what each of the things represents, you get points for each one of those things. And you get points for picking the right formula, and then points for your algebra. So show me as much as you can. Maybe all you get right is the time value, but at least it's a point. So take the time to show me what you know, and hopefully all is not lost on these story problems where you don't get to an answer. So, everything, we've got 1.5 seconds. What are you going to call that? Time. 1 point for you. Okay, 25 inches of belt wrap around the pulley. Be visual here. So you've got this pulley. There's a belt coming around it. It says 25 inches wrap around that. So what is that representing? S. Have a vision for it. 25 inches wrap around. That's our S value. So S is 25 inches. Radius is a half a foot. And label what you're trying to find. Angular velocity, what letter is that? That's butt cheeks. Well, now that we've identified the variables, let's pick our formula first, and then we'll take care of any red flags. Is there a formula that works with these 4 letters? S equals RWT. Okay, there it is. S equals RWT. Another point for you. So now, do we have any red flags to take care of? We got inches and feet. So let's take care of the radius. The radius is a half of a foot, which means we're going to make it 6 inches. Everything else is going to be good? I think so. So in place of S, we're putting in the 25. R, we're putting in a 6. W is W. Time was 1.5. And then point for your algebra. 6 times 1.5? 9. Divide by the 9. And 1 point for labels at the end of the story problem. 25/9 what? Because this is angular velocity. Radians per second, because our time value was seconds. Angular velocity is always radians per second, or radians per time. It's always radians per time unit, and our time unit was seconds. Good? That is in the notes when we did that. Okay, next one. Next and last. Number 2. Let's have 2 gears connected by a belt. Big gear, small gear. Connected by a belt. like a bike. So as these things start turning, is the number of rotations going to be the same? It cannot be the same. The smaller one's going to spin a lot more times than the bigger one is. Okay, but what is the same about this thing in terms of velocities? Angular velocities are not. That's how many times it's spinning. The linear velocity, the whole thing's going to be moving at one speed. So the trick to doing these ones that are connected, here's the trick, is that the linear velocities are equal. Angular velocities are not equal. Alright, so what's your information? We know this is 8.1 centimeters. This is 3.6 centimeters. This one is moving at 40 RPM. My question is, can you find angular velocity over here? Okay, what does RPM mean? Revolutions per minute, rotations per minute. So it's giving us two pieces of information here. Rotations per minute. No red flag. Okay, what do rotations tell us, or what can we get from the number of rotations? We can get radians, so I like to call this almost theta, because theta's radians. I can get radians if I know rotations. The 8.1 is our radius, and we've got a time value of a minute per minute time. And we can find big V. Big V, if you look up there, is arc length over time, but arc length is found by R and theta. So if you've got R, theta, and T, you can find big V. We've got R, we're going to have theta, we have T. So, R is staying 8.1. Time is per minute, so we're going to go with 1 minute. Theta, how do I get theta if I know rotation? Times it by 2 pi. 80 pi. Now I'm ready for plug and chug. I'm going to go with the F over T. To get the arc length, it's the fraction of the circle, which is 80 pi divided by 2 pi times by circumference, 2 pi r, all divided by 1. 2 pi's cancel. So 80 times 8.1 is 648 or 84?
I got 48.
Okay, 48 pi. What would be the units on that? This is linear velocity, think like miles per hour, centimeters per minute. Not that you need the label there, because we're not done. Okay, so now that we've got the velocity that this whole mechanism is moving at, we know big V over here is 648 pi. We've got R, and we are looking for W. Is there an equation that relates big V, R, and what we're looking for? V equals RW. So if you label everything, including what you're looking for, it's pretty easy to pick out the formula that you should be using most of the time. So big V is 648 pi. Radius is 3.6. W is what we're trying to find. Now it's just Elch. And a label. Anybody? I never did write it down first hour. 180 pi. And a label. So this is angular velocity. Radians per minute. Okay. Oh, stop that.